computer. Okay, go back there. Yeah, oh wait, oops, not that way. I gotta share the screen. All right, so he had I can't remember how he did it. I had to review his stuff. I just came across it. But I bet he's using some of the stuff that you use. Let's see what he's got there. What are those three green things, do you think?
5, you know.
Yeah, 5 green things and a
well, maybe,
kind of bread.
I don't know how many motors he has, but that monster mount may require just, you know,
Yeah.
4 motors for turning it. I don't know. It's yeah.
Second axis driven by stepper motors.
Can you hear?
Here's the
Can you hear what they're saying on that YouTube? When I play the YouTube, do you hear the conversation?
I hear it in the distance.
Yeah, it's not the loudest, I guess. I'm putting Tim is coming in here. I can boost it up a little bit. All right, just to continue.
software.
Hi, Tom.
Hey, Tim.
And here is the sun being imaged by a solar cell camera.
Oh,
The clicking rates, the variable rates to correct the tracking for the sun.
Tim, we're looking at Howard Royster's 1 meter telescope mount.
I did the
Where is this located?
I think it's California. He came to one of our meetings. He did a demonstration long ago, and it was January 2012 meeting. We had this 24-inch
Oh wow!
alt telescope mount, and he
That
had
1 meter looked like a sub no, at least what F3.
it could be. Yeah. And this one was all wood mounts and things, wasn't metal. But he had ways of encoding his to know where he was. I can't remember exactly how that worked.
Look at the screw inserts they use.
Pattern recognition, identify star field, drift imager, 2 camera system, wireless operation. Oh, now there's a 1 meter there. I don't know if that's the same one.
So I can't believe that that's over F4. It just can't be for a
Doesn't look
meter.
like. Yeah, some balancing weights in the back there. Oh, here it collapses all down, perhaps.
Yeah, and he travels. It's literally set up on a trailer.
Yeah.
An alt telescope, huh? Okay.
So it's all.
So there was actually a guy at the RTMC who was giving presentations on this alt telescope. It might be the same guy.
It could be. Yeah.
Yeah.
His mirror, composite spun auto figure mirrors, like 30-pound mirrors, 24-inch in diameter. What would that be? Composite spun.
That's what I'm wondering. Composite. So it's a composite mirror.
What's composite mean in this case? Sorlox.
Probably. What is the name of that stuff? They make glass. They make glasses, eyeglasses out of it.
Here they're showing how lightweight mirror somehow.
Well, the light, when you go to the optician now, you get glasses. If you have a really heavy prescription like me, they'll tell you polycarbonate. That's it. Thank you.
Yeah. I know that guy. I actually helped him set up his stuff on his truck. Yeah, he was at the RTMC.
You recognize?
Well, you helped him, King?
Yeah, I helped him with getting his stuff set up because it was a very relatively flimsy structure that he had. As big as it was. It was all made of wood, and it was just not strong enough. And the telescope that he had was actually very small. I mean, I think it was just like a 14-inch telescope or something like that. And the mount was meant for like a meter or so, something like that.
Yeah.
But he had some way of auto guiding to, so that it would track, even though it was flimsy. He was tracking okay with it.
Oh, I haven't seen him using it at night, I think. But I'm sure for astrophotography, it would have been a disaster. I wouldn't know how to control an alt telescope with an auto guider. I don't know if that would be.
It's called an alt.
Yeah, an alt.
Dick,
I mean, if you have
Dick,
an alt-as, then you can use an OnStep controller. So they make things for alt-as for Dobsonians also.
Dick, we were just talking about this guy, Howard Royster, and he making his alt telescopes and controlling them.
So he's got, okay. Oh, wow. Alt. Huh, I wonder what the heck an alt.
He had this 24-inch one that was all wooden structure kind of.
Those trusses he used, Tom, for a 1 meter for that upper cage, that had to just bend like crazy. That's just those.
One would think you'd have all kinds of tweaking on that one.
Yeah, that's going to flex all over the place.
Oh yeah.
Well, it's made out of balsa wood.
Oh no!
Oh, is it?
Oh god!
Well, that
Wow.
explains that.
Jeez. Yeah, not very rigid. Yeah.
Well, they have a honeycomb balsa that you can get. It's got a it's kind of got like cells in it, and the balsa's on two sides of it, so it's quite rigid, but very very light. I know that Harry Albers was messing around with some of that cellular stuff, and for a while he was trying to build his mirror box out of things that had sandwiched some type of a structure in between, some type of like a beehive type thing.
Well, Jerry, he's making his 18-inch with we call that, Hank, what's that called? Carbon
fiber.
Oh, yeah, graphite fiber.
Yeah.
what's that?
That's going
What's
to be
it
an
called?
amazing scope when he's done. I mean, I saw his mirror cell that he built, and he designed that mirror cell himself. And at the time in Santa Barbara, there was a machinist here that would there was a machine shop where the guy could, and he bought software especially to design the mirror cell, and then he designed it on his computer, and then took the program down to this guy who had the ChemCAD, the machine that'll cut it for you with all the digital, and the files matched. So he just handed the file to the guy, and the guy just cut all the stuff out.
Like a CNC or something like that. Yeah.
And if you ever got a chance to see it, it's really something. It's a really, really cool mirror cell for an 18-inch, and all designed by Jerry, and it's really, really nice. I think he had it anodized, if I'm not mistaken, and it's every single.
Did Jerry ever show us his carbon fiber telescope itself? Did he show that to us?
I don't think so, but he showed us the that mirror cell, and then of course
Right.
he went over to Joe Doyle's and cut a hole. Joe has a really nice drill press, and he cut a hole in his mirror over there.
What size mirror? That was the 14-inch, I think. I don't think that was the 18-inch though.
Is that right? It was a 14.
I can't remember. Can't remember.
Yeah,
Here's
but
Jerry. Jerry can tell us. Here's Jerry.
Oh, that's good. Yeah, that's good, because when he cut that circle in the center of the mirror. Hi, Jerry. We're talking
Hello.
about you.
Hi.
We're
thought
talking
my
about
ears
your
were
mirror that you wanting to know which mirror it was that you went over to Joe Doyle's and cut the hole in the center of the mirror out.
That's two mirrors. There's a 10-inch Cassegrain I was building, and there's a 14.5-inch corrected Dalkirkham I'm building. And I cored the primaries from the backside on both of those mirrors.
Oh, okay. But I remember that you didn't go cut all the way through. You cut.
No, you stop. I stop it at 220 grade, and which is the transition between rough and fine grinding. And then because you don't want to go, you want to cut through from the back with the same grit you're using on the front, so it doesn't cause big scratches in case you screw up. And then so at 220, then I cored in from the back. It took about an hour to go through the discs, inch and a half, an inch or something like that.
I was
And,
really surprised how fast that went. It was
oh,
surprising.
that was, yeah. Well, you have to be careful. And so then the next step is after that, then you finish fine grinding, which I've done. And then you have to do the polishing and then the figuring. And then once it's done, then you paint on shellac on the front surface of the mirror after it's all finished. And then you core through from the front with 220 grit, and the shellac protects your surface. And then you take the shellac off with turpentine. Stinks like hell.
You go through the front. I'm
Cut through
shocked.
from the front. If you come through from the back, the front will spall off in big flakes around where you cut through. It won't be a smooth cut.
Okay. Okay.
So you,
That makes
gotta
that
have
makes that makes sense.
you got to have an entrance wound on both sides.
Yeah. Well, that was I remember that being quite a procedure. On the
Yeah.
18 you have,
The
Would it-
18
would
that
you-
I have, the 18 is just a solid disc. It's a Newtonian astrograph.
okay.
If I can get the machinist to respond to me, he's going to finish the last two parts, and then I'll throw the telescope together.
Jerry, I was telling them about the mirror cell. I think it was for the corrected Dalkirkham,
Okay.
and that was done in town here by
I don't
By
have the Dalkirkham mirror cell yet. I have to make that. I'm still designing it. But I have the front end, which is I don't know if you could, it's not focusing on it. But it's a set of rings and the spider in there, and that's the secondary holder. And it'll be held up on struts.
wow.
So
Now that seems pretty lightweight.
it's pretty, yeah, I'm trying to make it as light as possible. So I don't know why it's not focusing. It's supposed to be an automatic focuser. I guess I'm confusing it. And
And
then
maybe zoom caused the problem, maybe.
maybe, and then this is the mirror cell for the 18-inch. Yeah,
That's focused pretty good.
yeah,
So maybe it's like how far away you are. Yeah.
yeah. So, and I've got the 8-inch or the 18-inch mirror finished and figured and coated and everything. It's in a box under my bed waiting. And I got the tube, which is a carbon fiber tube, about 20 inches in diameter.
So have you
That
cut
is-
cut the tube yet?
I haven't cut the tube yet. I'm waiting for the mirror cell support, which is kind of like a big spider at the back of the mirror, the back of the tube. And then the little plate that sits on the side of the tube that the focuser sits on. Those are the last two parts. I've got the secondary mirror and the spider and all that stuff. And the rings to hold the tube. So it should be pretty quick once these machinists get off their ass and finish my job.
Was that the one that you designed, the 18-inch mirror cell? Is that the one you showed me at the workshop? The one that you designed on your computer and then took it down to the guys to do the CAD cam on it?
I do all my own designs on this computer on CAD cam, TurboCAD, which has been bought by another company, so it's no longer called TurboCAD. And then I give that to the machine shop, so it's all ready to go on a CDC machine.
That's what I was thinking, CDC
Yeah,
or CNC. CNC?
CNC, yeah.
Computer
I'm,
numerical.
I'm losing my acronym
Yeah, yeah.
discrimination here.
Well, there's a few thousand of them now.
So there was,
Yeah.
back when I was working for Raytheon and Hughes, I kept losing track of all these acronyms. So I hunted up on the web a dictionary of acronyms, and it comes out it's about a quarter of an inch thick for the accepted. There's a set of these things for NASA, there's a set for the Air Force, and there's a set for the Navy, and they're all different. But the most interesting one was the SOC acronym, which is called the Society of Old Crows. And it was a group of fighter pilots from World War II that became consultants to the Air Force on designing what the pilot needed to feel and be able to do in new aircraft, as new fighter planes as they were developed. And a lot of famous fighter pilots were in that thing. And it goes on still to this day, not obviously with World War II fighter pilots, but, you know, succeeding generations of them.
You're saying the acronym was SOP, the Society of
SOC, Society of Old Crows.
Crows.
Oh, crows.
Okay, I was thinking crows. I said,
Oh, no, crows.
Okay, gotcha.
I thought you said pros.
Yeah, that's what I thought. That's
No.
yeah.
Society of Old Crows. Yeah,
Yeah.
there's even a commercial on TV. I don't know if you saw it, where they just, the entire commercial is acronym. The entire thing.
Oh, yeah. Well, you can get lost in that stuff. So the thing that happened to me, I started out when I was a kid in high school. I lived on the side of Mount Lukens up at the start of the Angeles National Forest, about 2,000, 2,100 feet. Very dry air, very dark. LA City hadn't reached out there yet. So I had, and didn't know it, wonderful skies. And so I did photography and observation. And then as I moved around, I went to UCLA and I went over the hill to where the marine layer was, and it was all foggy and everything. And then I moved to Santa Barbara, where it's even more foggy. So my hobby gradually shifted from using telescopes to making telescopes. So I'd rather use them.
We have to invent a fog telescope.
A what,
Yeah.
a what telescope?
A telescope that can go through fog.
Oh, that's a radio telescope.
Radio telescope.
Yeah, there you go. We're not quite there yet with
No,
those.
not for me.
Yeah, not quite there.
Who was the guy in the club, Jerry, that did it's not Jürgen, it's
Jürgen? No,
Jiri.
I don't.
I think it was
Yeah,
Jiri.
That did radio telescoping.
Oh yeah, he worked on
He
a
had,
ton
yeah,
of them.
he had a number of nice little 12-inch scopes or something that were antennas, and he'd set them up and demonstrate picking up Jupiter as it flew by and stuff. It was very good, but I don't remember his name. It wasn't Jürgen, you're right.
It was like Jiri.
Down here, take a
There
look
it
down
is.
here.
Jiri Polivka. Yeah.
So,
Okay.
But he worked on some radio telescope in Mexico.
Yeah.
Just huge thing. And then the government cut the funding.
Okay, well, that's common for government work. So, yeah, it was very interesting what he did. I don't remember his name though, but that sounds about right.
it's written
Yeah, it was
down
like
here.
Jiri.
We have one of his telescopes. He donated it to us. We have it stashed somewhere. Chuck would know.
Yeah,
I
he sold kits.
Okay.
I don't remember seeing it in our shed there. I don't know if we got rid of it somehow.
It folds up
apart.
to be nothing. You know, it's not like a big tube of something.
Chuck
It's
Chuck
an
might
antenna.
have it, Tom. Chuck
Yeah.
might have it. Because I think he
Maybe.
bought one of the kits. But he would take it to the museum, and of course, if on astronomy day, and if it was foggy, he'd be the only guy working.
What I'm looking forward to is when they can do the very long baseline stuff, you know, and I don't know if you can do that with the really small antennas, and if you can
Sure you
get it at the amateur level, that would be fascinating to me.
Yeah. That's quite a trick because you have to have the cables and the transmission time. so
Yeah,
that
you have to have
everything's-
an accurate time source.
Right, so
And it's all
everything's in phase.
post-processed. So that would be, the coordination would have to be there.
Yeah, it'd be tricky in a portable setup.
Yeah, I think so.
I think
I
we
wonder
already
if-
talked. I think we already talked about this, but there were a couple of articles in both the Sky and Telescope and Astronomy had that Puerto Rican telescope that
Oh, Arecibo?
fell in. Yeah, the Arecibo that caved
Yeah.
in. I think we already talked about that, but man, that somebody told me it cannot be repaired no matter what. It's just that
It's got to
just
be
too.
completely rebuilt. Yeah, it destroyed itself.
Yeah,
The Chinese have a larger version of it already operating.
Really?
Yeah. Now the Arecibo one was I forgot the name for how a rope hangs under gravity, but it approximated a sphere, and so it had to have a long antenna that stuck down to get the signal because there was a lot of chromatic aberration, not chromatic, spherical aberration. So the input was on what's called a caustic curve, and so the antenna had to match that. But the Chinese are trying to build one that's pulled and tensioned into a perfect parabola. And they've had a number of mishaps because it's not the way a thing like that wants to hang. It has to be pulled and distorted into the right shape. And they've lost some cables a couple times, so they've been having problems with it. But I think they're getting good results with it.
You know, speaking of that, the parabola is these telescopes that are spun. I think at University of Arizona, is that right? They spin these huge telescopes.
Yeah.
And they spin
8.2 meters.
They spin into a perfect parabola. I don't get that.
You can't, because there's bearing run out and there's all sorts of stuff that makes the bearings rattle and stuff as you go around. So it's fairly close to a parabola. They can get that way. In principle, it makes a perfect parabola, but in reality, it doesn't because of the technology. There's always dirt in the bearings or something. And so they get close enough so that it's just minor grinding and figuring that they have to do to fix it. But it's most of the way there. There's no stage that's used to be called the hogging out phase, where you just remove a lot of glass to get from flat to the sphere you want.
Oh yeah, the Hale telescope. I think I can't remember what the number was. It was something like 30 or 40 tons of glass that came out of that.
Yeah. So this is actually a picture, whatever he's come up with. This is the rotating furnace at the University of Arizona mirror lab. And this thing rotates and the mirror inside rotates, and it gets hot enough to cause the glass to flow. Glass doesn't have a melting point, it's just more or less viscous depending on the temperature. So, and that's the mirror that rotates inside. I can't tell whether this is pre-rotated or post-rotated. I think it's post-rotated because it's usually a lot of chunks of glass before it's rotated and heated.
I just don't get how they can raise that temperature that much and rotate it.
Heaters, it gets really hot in there. That's the mirror cell, that red thing.
Wow.
Yeah, there's the mirror in the mirror cell. It's being held up by these suction pads, I think.
8 meters. What is that?
8.2. And they fixed on that size because that's the diagonal size of the freight door on the laboratory door. So if it's 8.2 meters, they can tilt it 45 degrees and get it out the door.
Oh my God. Wow. What is that? 40 feet?
I think they're making like 6 or 7 of these mirrors for the Great Magellan telescope or something.
Yeah, there's 7 mirrors, and they've made
the giant.
The giant Magellan, yeah. So it's going to be. Yeah, go ahead.
I heard that there might be funding problems on keeping that thing going. That
Listen,
they're
there's
always-
funding problems on every scientific project that's ever been or ever will be
Yeah.
proceeding. There's stops and starts and fits and all sorts of stuff. I don't know what this guy's doing here, but
I think they're just cleaning out the back or something.
I don't know.
Yeah.
The mirrors are pretty thick, so
I'm trying to figure out what the 8.2 meters is in feet. It's got to be near
Times 3.
30 feet.
well, the 100
3 times,
inches,
yeah,
100 inches,
roughly.
5 meters,
more than 3 times.
2.5 meters.
Gonna.
So does anybody have anything they want to present in particular tonight?
Yeah.
Did you?
Yeah.
Hank?
Yeah.
Oh, I can show you, since you were on mirrors, not, sorry to interrupt you, Hank, but I can show you my pictures of that mirror lab if you want, or we can wait later till Hank's done.
Yeah,
Oh, yeah.
Hank,
Oh,
Hank is in
that
here.
looks, yeah,
Well, this is with the RedCat, Dick. So this is
yeah, sure.
So
Yeah,
it worked out pretty well. I just did it on my AVX. I had to set up my AVX with the Raspberry Pi and all that stuff. I mean, I should know how to do it blindly, but it's been a while. I was a bit rusty on my AVX, but the resolution is good. I have another one here. This was the original from at full size, full resolution from DSS, and you can see it's all the way round into the corners. The
Oh,
guiding
yeah.
wasn't even that
Oh,
great.
yeah.
The
Yeah.
guiding was like 1 arc second or so, but
Oh,
you
yeah.
know, it's just pretty
Yeah, it's
amazing.
very forgiving.
Yeah.
Very forgiving.
And, by the way, I did not dither, so you can see the stripes here. I have to learn how to dither. But aside from that, I'm very impressed with the resolution that I get from the telescope.
Mhm.
So
Yeah,
anyway, I thought I'd show that. I'm pretty happy with the performance. Yeah, I cranked up the colors a little bit, but frankly, I don't know if that green, if that's because I didn't take darks or
No,
or
you're gonna
gradient
get,
or something.
you're using a DSLR, right?
Yes. Yes.
Yeah, you know, you're gonna get green channel distortion because there's 50% of the receptors are green filtered and 25 are blue and 25 are red. So the chances of you getting green distortion are quite good. In PixInsight, what you would do you do something like selective chrominance noise reduction, and then you just do it against the green channel, and then that would take that out. That would take most of that
Yeah,
out.
but I equalize all the channels because I use DSS to, I don't know if you know, you're familiar with DSS, but you get 3 color curves and you can vary the width and the position. So
Yeah.
I'm sure before I start out that those peaks are right on top of each other and equally wide. So all the colors are
Right.
equalized.
Yeah,
So
yeah, you're gonna get some green channel with the DSLR. That's just the way it
Yeah.
is.
So when I start out, since this is a modified DSLR, it has much more red than green. and
Oh,
blue.
okay, okay.
So that
Yeah.
would be the dominant color, but I equalize everything. So I just take advantage of the amount of red by just reduced noise in the red channel.
Oh,
So
Great.
anyway, I also have
I
another
love
one.
that, yeah. Yeah, that's such a nice one. Yeah,
And-
the focus is a little tricky.
Well,
but-
actually, I use the Bahtinov mask, and that works fabulously well with.
Oh, yeah, that's right. Yeah, that's right. You
For
have
those who
that.
don't use a RedCat, it comes with a little Bahtinov mask that's just a plastic insert in the lens cap. So you can screw the top of the lens cap off, and then you've got a Bahtinov mask that you can put on top of the.
That little scope just seems like it is killer.
It's
For what,
still-
Yeah. It is a
50
very good.
millimeters?
Yeah, yeah. The
Yeah,
focal
it-
length is 250.
It's
an,
a great
yeah.
one. And of all of the mosaics that I've done, the only one that is artifact free has been done with this RedCat. I'm still trying to work on getting the NP127IS to be artifact free. And I have some stuff I could show you on that one too.
Yeah, I have a couple of versions. I picked the one that was the reddest. I don't know. Sometimes it shows up. Well, depends.
The
on
red really came out on yours. That's what I noticed.
Yeah,
I
I
saw it.
think this one, it has a lot of red in it, but I started
Yeah.
out with something more moderate. It doesn't matter. They're all. See, this one is a little pale, so I thought, let's crank it up a bit. Anyway, that's just a matter of taste. And I tried another one that was not as successful. Let me see if I have it up somewhere. That was the heart and soul, and that's a difficult target. And
Oh, yeah.
I had like 4 hours of exposure or something like that. So, but it was no success. I'll show you what I've got.
You can get both the heart and the soul with that red
So-
cat. I'll show you a shot of it too.
So
Yeah,
this
there
here,
you go.
this here shows that I have a gradient off to the right,
Oh, yeah.
and really the red, which is the nebulosity here, gets overshadowed by all the stars, and it looks like in the center there's more light. So again, I did not take darks, and I should have done that.
Mhm.
So maybe it would have been better. And I processed it and I cranked the hell out of it, and it's not pretty, but it looks like this. So I got the
Oh, yeah. Yeah.
this is I think it's ugly, but it was an experiment. What I did is I took this one here, and first I removed all the stars with StarNet++, and then of the starless image, I got rid of all the gradients and so on, and in GIMP, and then added the stars back in of the original, and that's how I got this one. But I don't think it's pretty, but
Why don't you like it? It looks good to me.
yeah, well, it's got stripes on it and so on. It's
Oh.
ugly. Also,
You know, the
from-
striping, that might be because of the darks. You didn't do any darks.
well,
so
it's
all
also
that
because no,
striping-
it's because of the guiding, because I did not
Oh.
dither. I did not dither. It's the same.
Okay. Shoot, I
But,
don't dither.
I way overstretched it. So,
Oh,
I-
okay.
but I think this, it's less suitable for these kinds of targets because it's only a 50 millimeter aperture. So the footprint of the stars is relatively big compared to the nebulosity, and it's. I think with a larger scope, you'd have more success, I think.
Mhm.
So anyway, and then I modified my G11, and I wanted to show that too. Remember, I had these timing belts that I showed. So I put
Oh,
them
yeah,
on.
yeah.
So here you can see it. It's kind of ugly. Well, not super ugly. So the one at the bottom is in the right place, but the one at the top here for deck, unfortunately, it was meant to go 45 degrees counter clockwise, but the first position that I tried was actually 90 degrees clockwise. I wanted to have it inside as much as possible, but then the motor hit that cone-shaped piece of the mount, and so I had to flip it. And so now it's 90 degrees or 45 degrees off. I'll fix that later. But anyway, it's on there and it's fully functional. Let me see, how do I get to the next one? Okay, here. All right, so this is the altitude. No, sorry, this is the RA axis. So it's a 3-to-1 timing belt, and the motor is here at the rear. I've got a rubber band around it because it holds the Ethernet connector at the bottom, because these things were glued on, but I had to loosen that, and now it's hanging on by a rubber band. But anyway, it doesn't matter. On the rear, you can see the spring of the spring-loaded worms, and I had these little metric screws that came in handy. That was from some other project.
Hank,
And,
what is the spring is to keep backlash away?
that's from the spring-loaded worms. I can just that's a different part. It has nothing to do with this here, but it's it's to keep the the worm pressed onto the ring gear,
Okay.
basically. So yeah. I mean, I have other pictures of that if you're interested, but I think I showed that before, didn't I? I'm not quite sure. I think I did. We can go
I
back
missed
to-
it, but that's okay. That's okay. I
All
just,
right, so let me finish this then. So this large wheel, there's a 5 millimeter axle that goes through it that is connected to a flex coupler on the other side, underneath this cover plate, and in between that it's seated on a bearing that's clamped into this piece of wood, so that it's a 5 millimeter axle, and the bearing had exactly a 5 millimeter hole. So I had to really hit it in there, beat it in there with a hammer. It was pretty tight, and if you do that, you can use some nuts and so on to protect the bearing, and that you hit it, put the pressure on the right part. So that went fine. And after that, I had to hit that bearing plus axle into the piece of wood, because I deliberately made the hole a bit too small so I could just clamp it in there.
Yep.
And it's very tight. And that axle was hard steel. I had to use a grinding wheel to get it get through it. I used a metal saw and it had no chance. I think I need to go to the store and get a new one.
Now the shaft is going through the center hole on the bearing, and the bearing turns. Is it like a ball bearing, or is it?
Yes, it's a ball bearing. Yeah, just like
Okay.
a roller skate bearing, sort of like that, but then smaller. It has only a 5 millimeter diameter inside,
Okay.
and you could easily fit 3 next to each other inside a piece of plywood. I think. Well, at least 2, but
Wow.
1 is enough. But it's very smooth, so this should work really well. Now this is an OnStep system. Unfortunately, in order to get this working, the frequency of the pulses is like 3 times higher, and I was not able to get it to work better than 1 degree per second when it's loose. So it's 1 degree per second. It used to be 2 degrees per second, and frankly, I think I could even go higher, even 4 degrees per second. That's nice and fast, but somehow I tried all kinds of combinations, but the software is apparently somewhat sensitive to this. And anyway, slewing is the least of my concerns, actually, because when you have a target, you only slew to 1 target every night, and if you have to wait 1 minute, that's fine.
I have a question for you. Where did you get your bearings at?
Well, I ordered everything on Amazon.
Oh, it's an Amazon. Oh, okay. I thought McMaster Car, but no, it's.
No, not McMaster Car. So when you order something, I was looking for timing belt. Then they give you suggestions. You might need this or that, and I think it was all there. So
Okay, thanks.
yeah.
Interesting.
But,
Yeah, I like the stuff you build. It's clever.
Very
Yeah,
nice.
it's actually quite solid. It's mounted, by the way, on the rear is a metal plate. So if I go to the next one, so here you see this orange thing. There is a metal plate that was for my EQ Star controller. So it's and that is actually really rock solid. So it's supported mostly by that. And here you can see how tight a fit it is on the RA side. Everything fits. And I need to keep this area free because you need to be able to turn this big wheel here. That's for the declination, for the elevation. That's how you set the elevation of the scope. The RA axis, the tilt of the RA.
I think that's declination, isn't it?
Well, actually, it's an alt-as. That's what is underneath the RA and the deck axis, right? So there are 4 axes on an equatorial mount, and this is the altitude axis of the alt-as system. So this is how you tilt the whole thing up. This is how you do the polar alignment, and you need
I
to
see.
get
I see.
So this one carries the whole weight of the scope, and the other one, the alt, is much easier. That's just the rotation around the vertical axis, and there are 2 knobs for that. Anyway, so let's see here. The deck looks like this. Same story. Yeah, and so here you can see, if you're interested in a spring-loaded thing, what I did was, and this is also what Losmandy does actually. They screw the 2 blocks that have the worm into the cover, and the cover is now the thing that connects these blocks together. So what you do is you squeeze the outer block towards the inside. So the inner block, that's the one that you see here, it has a pivot that it turns around. So that's meant to stay in one place by Losmandy. First, they worked with these blocks were just screwed straight into the base. But with the spring-loaded worms, you loosen the bottom 2 blocks, so it basically floats on the base that you cannot see here. Yeah, you can see it here. It's this piece here. If you can see it, that's the base, I think.
Well, where's the block that you're talking about?
They are underneath the cover, so it's the block that are on both sides. That the blocks that hold the worm.
Now the spring is it pushing against the bolt?
Yes, so that bolt is screwed into the first block, and that spring provides both a tangential and radial pressure. The tangential is it's pushing this thing out, so the pivot is pushed against one side of the hole, even though the hole is pretty tight fit. So
that keeps it tight against the gear.
Right, and because the screw, it has a momentum, there's also a radial pressure that presses the worm into the ring gear. The problem with these Losmandy is that they don't have a round ring gear. So either you live with a lot of backlash, which is just ugly, or you do something like this. And everybody who has a G11 complains about this. And everybody does something like this. And Losmandy now sells the spring-loaded worms. It's a product, even though it's more
Wow.
like an adjustable, spring-loaded adjustable mechanism. Because most of the time, the way they sell it, the spring-loaded worm is actually disabled, but they have a spring that lets you easily adjust the whole thing.
I'm still not absolutely clear on it, but that is clever.
Okay. Let me just see if I can find something more here. Let me see here, because I have some. Let me see.
'Cause I think a lot of guys really complain about backlash and how to keep the, don't some people actually add a little tiny bit of weight? They don't balance their scope.
I do. Not on deck though, just on RA.
Just on RA?
Yeah,
Yeah.
RA, you got a little bit tougher system there with the motors and stuff. On deck, I just balance it perfectly as best I can. And the thing I have found is it's position dependent. It depends on where you're shooting and what you're shooting as to how the scope is going to react. You start to get towards the meridian and you got something like the Veil Nebula, you're at that tipping point.
Yeah.
You're going to have all kinds of problems. You just can't
So
get
Tim,
out.
this
Okay.
is maybe a better picture here. Let me
Okay.
see if I can. So here you see the outer block. See that you see the cover here with the scratches. That
Yes.
square piece is the outer block, and the worm is seated on this block in here. And where this other screw, it's where the other block is. So the worm is inside here, and I don't have a picture with the worm open. I have it somewhere else, but
It's
I think
inside that rectangular
yes.
metal piece. Okay.
I mean, I can try to look for it if I.
It's okay. It's okay, Hank. I think I'm getting it because that you have the tangential pressure of the screw as you screw it in to keep it pushed against the gear.
Yeah, it's a quick and dirty version of spring-loaded worms. So now you don't want to have any wobble. So you don't want this cover to move up and down or whatever. So this screw still has to be tight enough that it keeps it down. And so what I did is I used a little Belleville washer that provides some tension, but still allows the thing to rotate without too much friction.
Wow, wow, that's really clever. You're gonna have to really kind of tease that so it's just right.
Yes, yeah. So this hex bolt here is meant to set the position of the spring. So if you need more momentum, you move it out a little bit, and then the momentum through this screw is larger. That's the idea. Anyway, it was a quick and dirty.
I really like that. You put the nut inside the spring. That's cool.
Anyway, it's I didn't want to do any destructive modifications of the system just in case it was a failure. So this was a painless modification. It's basically just a screw and a spring, and that's all you need, and a Belleville washer.
I think there's a lot of strength in simplicity. I really do.
Yeah.
Because if everything goes wrong, you just lose a simple thing. But the simple thing in this case works.
Yeah. And this is what is this? This is declination, right? I've got it for RA as well. It's the same story. This is
I like it.
I think this is RA. Yeah, whatever.
Because so Losmandy sells this now.
Well, okay, so not the same thing, no, but the idea of a spring-loaded worm was invented like 10 years ago, so there's some people who are pushing for it, but it takes a while to get these things going. And honestly, I'm not sure if it's a good thing, because the disadvantage of having a spring-loaded worm is that in order for the spring to work, it has to be engaged enough to move the load, and that causes additional friction. So it gets harder to move it, but also the worm wants to move up and down because of the friction. So you can get into cases where you've got an extra vibration in the system as a result. It's all pretty tricky. So, and if you just leave the blocks in place the way it was meant to be used, then you just have a gentle push, but you don't really have to push the worm into the grooves of the ring gear. And so it has a disadvantage. So far, it seems to work pretty well. It works great for slewing. It doesn't bind anymore like it did before, because with these systems, it has a fairly large ring gear and it's very heat sensitive. So it may work inside. You put it outside and let it cool off and binds up. So
will eventually that gear, will it wear enough so you have to replace it?
oh, maybe, but that will take
But
a long
years-
time.
Yeah, okay, yeah.
Yeah,
Are you
and
doing that to both axes? Are you doing it to declination as well as?
I have for declination as well, especially for declination, because you've got backlash there. So that's exactly where I want to have it work most. I mean, for RA, you don't really need it, frankly, except for slewing. I mean, you don't want it to bind up, right? And so to prevent that, this works great in both axes. But when you're just tracking, your concern is mostly with deck, because RA is loaded on one side, and you don't really have a backlash problem. But for declination, you do have.
That's interesting, because I
Yeah.
don't ever do that on deck. I have problems with a lot of times with little south motion. But what just eventually happens is it settles out and everything's fine. Just in a perfect balanced mode, it pretty much works okay.
Oh, good. Yeah.
There are issues though. You get to certain spots, like I was shooting C214, that area right there. You get the weights just all the way down, and you'll get more deck rock in that when I was shooting that particular position. It's position dependent too. Depends on where you are. But if those weights are straight down, there's like a little slop in there, and then once you get through that period, you're fine for the rest of the time. You can just shoot your guts out, and it's not a problem. As a matter of fact, that's what I did. I probably shot 12 nights out of this last lunar cycle. It's just shooting pool.
So, and by the way, this orange plate, that is a remnant of an EQ star control system that I got from a guy in the Ukraine one time. It didn't work well enough, and I'm not sure if it was my mistake or not, but I decided to go with OnStep. But this plate is still very useful. It's a nice steel plate that has the screws in the right place, and side, the holes are right for the motor. And also the flex coupler that's inside here. Let's see if I have a picture of the worms for Tim. I'm not quite sure. I have it somewhere, I think, because at some point.
I'm glad you got to use the RedCat.
Oh yeah.
I can't get over that scope. I cannot get over that. The images you guys are getting with that for such a small scope, and then you hook a DSLR on it, right?
Yeah.
Hanging it off a RedCat, like a full size, like Canon, or smaller.
I'm hooking mine on there. I've got a 6D with a battery pack. And the thing that's nice about it is it's front focusing, see, so you're getting no tube sag.
Okay.
So
that really,
that's why you got, when Henk was showing the corners, that's why the corners are so good, because you got no sag.
Yeah.
Yeah, and what I also like is you have to screw the DSLR onto the telescope. It's not like a T mount, a T connector. Normally you have a T adapter, right, and you stick it into the focuser opening, and you've got like two screws. But usually the opening is too large, and you don't know exactly what those screws do. So it may cause a little tilt or slop or whatever, or off center.
Look at that! Look at how small that guy is.
You just screw it on. You just screw it on to the telescope. And the other thing is that also the focuser is a nice helical focuser that actually works pretty well. So yeah, it's really
tricky,
very well done.
Yeah, it's so nice.
It's a quad. It's not just an Apo. It's a quad. So
it's a quad. It's a pistol.
Yeah, it's got the triplet for the color correction, and then the fourth element is to create a flat field. So you don't need a field flat. You don't need a field flattener or anything, and it's pretty heavy.
That's how Nagler built his first Genesis scope. It's a 4-element.
Right.
Yeah, and that's what the NP127IS is.
Yeah.
If
you see that picture, by the way, if you can scroll up again, to see that RedCat, that one, for instance, the one at the bottom that to the left, that red holder, that's actually, you can screw it off and it becomes the light shield. So you flip it the other way around,
Yeah.
and that reveals the focuser that's underneath it.
Yeah.
That you see in the upper corner. That's where you see the black ribble. Yeah, exactly. That's the light shield basically. So you screw that off. It took me a while to figure that out.
Mhm.
God, what the heck? Where's the
Yeah, where's the
focuser?
dew shield?
Where's the focuser? Where can I put
Yeah,
my?
where's the focuser?
Where
Yeah,
do I put my T adapter? Holy
I'll
shit.
tell you, if I ever get into astrophotography, I'm gonna be looking at that little guy. 'Cause
That
they're
would be
only-
a wonderful instrument to start with. Because
Yes.
look at your focal length. It's very forgiving. You don't have to
Yeah.
worry about, you get these Smith grains and you got to be right on. You got to.
Oh, look at it. There's the little focuser. There's the focuser.
Yeah.
Yep. So yeah,
Front
That's
focusing
the-
lens.
yeah.
I mean, not
The
focus or
focus
anything,
lock
but-
I don't use because it seems like when I focus lock, it moves it just a smidgen. So I just leave the focus lock off.
Oh, is there a focus lock? Oh,
Yeah,
I didn't know.
it's basically just a gem that thing.
Okay, because
Yeah.
I didn't use it. I just
Yeah.
focused it
I
and
wouldn't.
I left it alone.
It shifts it. Yeah,
Yeah,
it shifts
yeah.
it when you lock it.
Oh, okay.
It's not
So-
like the NP127 IS where you have two focus. You have two knobs. You got to do
Oh.
both knobs for the focus.
Can you go back to the optical layout, scroll back up a bit, right there? Oh, yeah, no, there. How many lenses are in there? It looks like
There are
6.
4 lens groups.
I only
You got
see
the
3 lens
You
groups.
got your 3 typical APO types in the front end, and then there's a rear element, which is actually a doublet.
Yeah,
That's your Pitts pole element.
so
right
there's
there.
three groups.
Interesting.
Right.
Well, yeah, I mean, you got a triple acromat in the front, and then you've got the rear field flattener.
Yeah,
Basically, that's
nice looking lens.
Yeah, and it's fluorite glass, right? So it has a very good
Uh-huh.
color correction.
Well, all those surfaces, you can get rid of color.
Yeah, yeah.
It's a wonderful size because the whole thing is built around basically that 2-inch platform that is so common in telescopes.
Is its aperture the 51 that I see around?
Yeah,
some?
it's a 51.
Yes.
Yeah, it's a 51 millimeter aperture. Mhm.
And it has that little, what do you call that little focusing screen? It's built into it.
Bahtinov mask.
Oh,
The Bahtinov mask. Yeah.
yeah.
Bahtinov mask, and it's just built into the cover.
The lens cap.
Yeah, that's
Yeah.
the one.
Damn, it's got it all. Look at that right there.
Yeah, there's been a lot. If you look at the design of that thing, in my personal opinion, there was a lot of time spent trying to figure out how to make a very nicely designed instrument, and
Yeah.
they did a good job.
Yeah, they did.
And this is William Optics, right? If you go to their shows, then you see mostly small telescopes. They've always been doing that. It's a family-owned company, and I think this is a great product. It really is.
Mhm.
Oh, you guys are, between Hank, you and Dick showing those wide fields. I mean, Dick blew them up. He just kept blowing it up and blowing them up, and they're still pinpoints.
Yeah, that one of the pipe nebula, man, that thing, I can't believe it. I still
Yeah.
am blown away with that thing.
You kept
Yeah.
blowing it up, and it was still a pinpoint. I
Yeah.
could not believe that.
Yeah,
Because
and
usually,
that's the
what they
only
do-
one. That's the only one where I've gotten a mosaic where there's no artifacts. Yeah.
Wow.
Actually, that's not true. I did one with the 10-inch, and I kind of wanted to talk about that too, because I've got a little theory about that. But anyway, let's let you guys. Oh,
Now there was tonight. I guess the guy didn't show up. There was going to be there's a lady that works down at the tennis courts, and her dad lives. I think he lives in L.A. He was. I think I sent around something to somebody. He wanted some help with a telescope or a mount, and I was asking Tom about one of the mounts that he talked about one night. But turns out, Tom, that guy, it wasn't so much. I don't think it was the mount that was the problem, but the last time I talked to the girl, she said her dad, or he actually emailed me, and I thought he was going to come tonight. And his name's Ira, and I was in the near future wants to get a refractor. And I was thinking, because he probably had the scope he had, it might have been a refractor, might have been a reflector, but it was small. It was kind of like the Costco scope, you know. But this little RedCat, can you use it visually? I mean, is it something you could?
Sure. Yeah, you know, and you got a reasonable. Let's see. I'm trying to remember the focal ratios. 4.9, I believe. I can't remember. Is that right?
4.9. But I
Yeah.
mean, that's
It's
you
pretty
know,
good focal ratio. So I mean, you could slap and you could put a 2-inch eyepiece on the freaking thing if you wanted to.
2-inch.
I'm sure you could. It's all set up for 2-inch. So as a matter of fact, the camera uses a wide mouth adapter. For my 35 millimeter, I got to get the full 51 millimeter wide mouth T adapter for my camera. So you could put I've seen you could put 2-inch lens on there. I don't see why you couldn't. Now maybe you'd have vignetting. I just don't know. You know, with a format
I was gonna recommend to the guy to look like an Orion telescope. So I was gonna actually ask you if he showed up tonight. I was gonna have you guys, you know, put in your expertise, because I know that you guys have great ideas on which refractors that people can start with.
You know, it depends on what he's going to use it for. If he was trying to get into astrophotography, we had that one gent on here that one night, and we never really got around to talking about scopes too much, and I never saw him again. But that would have been my recommendation for a scope for starting, or a starter scope for astrophotography. I would seriously recommend that RedCat. You know,
I mean, I can't believe and you know, it's not that expensive. I think it's
it's 1/10 the price of an NP127IS. Let's put it that way.
That's right. That's right. That's right. And the results you're getting are just astounding.
I can't believe the freaking thing.
But
Yeah.
I would not use it for optical. I mean, it's really best used for astrophotography. That's what it's made for.
Yeah,
And I would have to agree with that. Yeah.
50 millimeters is not too much light gathering ability. You know, you'd have to be in a really dark sky.
Yeah,
You know,
no, it really wouldn't. And you're such a wide angle that you know, but I think though for Milky Way stuff, I would challenge you guys. I think it would really, it could look really good in a dark sky. I mean, I don't know if you'd want to use a 2-inch eyepiece or using, you know, the smaller version, but you know, it would have to be tried out. But I agree with Henk. It's primarily an astrophotography.
Yeah.
And I would say that if you're into visual stuff, you might want to choose another instrument. You may even want to consider going to a Dobsonian.
For visual, you might as well look through a viewfinder. Really, I mean, actually, I have a viewfinder. It's a pretty damn good viewfinder.
I got
a darn good
viewfinder from Stellar View that I think is a 50 millimeter.
Yeah, I have the Stellar View Rascal, which is actually it's not a viewfinder, but they sell it once in a while for. And then it's good. It's kind of fun if you go on a hike, then you bring it with you because it fits in my fanny pack, and you can hand it and look at the stars.
You know, Tom Whittemore he had a buddy that died, and he left a lot of equipment to Tom, and he has one of those TeleView 85, the 85 TV 85, I think it is. And Tom takes that to a lot of little outreaches. He'll take that because you could just sling it over your shoulder and walk in. And you know, I think that would be kind of like for a refractor. That's I think minimum to me in my mind. That's about minimum.
That would be fun. I have my I have an 80 millimeter Apple from Explore Scientific, and that works great for visual. So I enjoy using that. I have a little mount and an Explore Scientific Nano, and they go very well together, basically. So that's fun for visual.
Yeah.
But I like my 20x80 Celestron binos as well, which are also dirt cheap. You know, it's $145.
Yeah. Well, we'll find out. One of these nights he's going to show up here, and we can discuss stuff with him. And you know, it'll be interesting to see what he kind of wants to do with it and how much he wants.
Visual, you need something larger. And I would actually, I also like my Mac Mute. It has a very crisp view.
Oh, that
Huh.
thing is really cool.
Oh, that's,
Isn't that-
yeah.
It's
Huh.
like that, right?
Yeah, the Mac Cast. Yeah, these have high f ratios, which means that the light gathering power is not going to be that
But
great.
it'd be good, might be good for planetary.
Yeah, but how many planets are
Marginally,
there really?
okay.
It's like, yeah. But
The
yeah.
scope you're looking at was donated by Don French to
Oh.
SBAU, and it's a nice
Okay.
little assembly. I was trying to focus with it though, and it would not come into focus. So I'm not sure what's wrong if somehow the focuser is disconnected from the primary or not. I'm gonna have to try playing with it some more. So don't know what happened.
Something might have slipped internally and be out of alignment.
Yeah.
What's the aperture on it?
I think this is a 90, I think.
Okay.
Yeah, I think it's 90.
How do you
Something
focus
says
those?
102 millimeters.
Do you focus them through the primary, or how does it
Yeah.
work?
The
Okay.
primary is a little focuser in the back, just like a Cassegrain,
Yeah.
Okay.
Yeah.
but it's kind of cute. It's, nice size. And
Yeah.
I'm not sure how it compares to a RedCat, but
Oh, it won't have the field of view that the RedCat does.
Yeah, RedCat's,
Nowhere near it.
yeah.
Yeah.
Well, that
I'm not
Mac, that Maksudov Newt that Hank has, I've seen pictures that he has with that. That thing's unbelievable.
Yeah, and it is also good for visual. Actually, I enjoyed using it for that, and it's a 6-inch diameter, so the focal length is 700 or something like that. So it's an f4, so it receives a lot of light. Well, for visual, of course, the amount of light that you get depends on the eyepiece as well. So you've got some.
That was the Levy scope, right? The
Yes.
Comet Hunter. Yeah.
Yeah.
Mm.
Levy and the guy from Explorer, Scott Roberts, I think.
I kind of wanted to show you, we seen, you guys have seen this before. This is my North American. And I wanted to
Oh, yeah.
show some
Oh,
of the
beautiful.
artifacting. See, there's some there, that's pinching. Okay. And then there's, of course, this little ray thing coming out probably from this guy here. So when you get these guys on the boundaries where the seams are between the panels, those sorts of things happen. That's the only place I've really seen it. Most everything else is,
This was your 127, by the way?
yeah, 127 IS 3-panel mosaic.
Okay,
Yeah.
good. I'm
Yeah.
relieved, because I thought if you did that with the RedCat, then I feel very humble.
Oh, no. I know you're not gonna get that. Yeah,
Okay,
yeah.
good.
Well, I thought this came out really good because it had the blue.
I can't see the problems you're talking about.
Well, there's pinching here. See that? Can you see my little hand jumping
Yeah.
around here? That's pinching.
It's terrible.
And then there's also this part right here. So
I have no clue what's wrong with that. It looks
well, you
fine
got
to
a
me.
ray coming out of here. Where's the ray? See, that's not real. See, so you got these
Oh my
rays
God.
coming out of here. And so those are artifacts that are produced by the mosaic.
Okay.
And so that's what I'm running down. So I started to look at this problem and I'm going, okay, what is it about, let's say, for example, this guy right here that makes this guy work? If we look at the seams, there's nothing. There's no
And
problem.
what did you use to make the
This
mosaic?
is a 10-inch astograph. There are 2 panels in the mosaic. This is the first mosaic that I ever did. And you look at it and you think that with this instrument, with the diffraction spikes, you'd be getting all kinds of problems, right? You'd think that if anything, with these spikes and everything like that, if you tried to do this mosaicing where the seams are, you'd have problems. You'd have rays and everything like down here, but you don't see anything. Why?
So
Okay,
did you?
so I started to look at this and I said, why is this artifact free? Okay, because now here's the problem. Where these artifacts are occurring are where there are bright stars that are near seam boundary. What if you had a way to make the bright stars dimmer? That would be a composition, wouldn't it? In other words, if I take and I layer exposures, say in this case, 6 minute, 3 minutes, 1 minute, and then 30 seconds. If I layer those exposures one on top of one another, renormalize the data so that it's at 1, okay? That means that the brightest areas in the image are going to be brought down, and those would be the stars. So if I can bring the star images down, I can possibly reduce or eliminate the artifacting. And that may be one reason why this baby came out the way that it did. There's just nothing wrong with it. And I couldn't quite figure it out. So what I did was I go, okay, I'm going to do a mosaic. Well, let me show you what I'm doing first before I go there. This is what I'm doing. Hang on a second here. And that guy there. So this is C214 down here, and this is NGC 7822. This was shot with a RedCat, and it, it's kind of like some of the stuff that, it's highly contrasty image. Okay, so what I thought is I was going to do a mosaic of this. Well, it turns out there's really not a whole lot here to mosaic with the MP127IS. But what I ended up doing was I said, okay, I'm going to mosaic it, and I'm going to, what I did was I took 7-minute exposures for each of the 2 panels is what I'm doing. And I took 7-minute exposures and 3-minute exposures for each of those panels. And then I did compositions on those exposures. And then what I'm going to try to do is mosaic it and see if I can reduce or eliminate the artifacting on this whole thing. This is the biggest problem that I'm having with this whole thing is the artifacting. So here's the setup, by the way, right here. Basically what I got is, there's the NP127. And you notice I got dew heaters on. It got pretty cold some of the nights and fogged up eventually. So I put dew heaters on, and what I normally do, I've got a little plastic box that I put the lid on top on this glass table. You can't see the glass table, and then when that's on there, I can tell when it starts to get wet on top. That's the first indicator. Second indicator is the glass on the tabletop. So I start looking at these things, and I always put dew heaters on. So I got pretty big strip heater. I think it's just about 15 or 16-inch dew heater here, and then a smaller dew heater here. So, and that's about where I ended up, I think, when I quit, filming, shooting, which was probably about 11:30 or so, something like that. So that's basically the setup that I had there. So let's see here.
Where'd you get the box that your computer is in for shelter there?
Oh yeah, I got that on Amazon.
Was it made for this, or did you just do it?
What it is, the whole thing folds up, and it folds up into these sides here. They kick in, okay, and then of course you got a top and a bottom, and as you can see, they're kind of serrated here, so they kind of interleave together.
Yeah.
Then on top, and then there's a bottom which is stronger. So it's kind of like what it is it's kind of like one of these breakdown cargo containers.
Okay, so it's a box that breaks down into something flat.
Yes, that's it. Yeah,
okay.
And so I basically got my my laptop here running PhD 2.
Yeah.
With the trender up, you can see that it's trending really good. I could barely might be able to zoom in there. Yeah, I can't see it really well, but it's trending probably less than one second of arc. I mean, you're probably even less than half a second because it's a real good target. So this is what I'm talking about. You have to choose some of these targets. You have to choose them pretty well. And then of course the iPad down here, that has the Star Atlas, and it also is running the shutter for the camera.
Now, what was that box called on eBay? Just a box?
Oh, not eBay, Amazon.
Amazon, excuse me.
Let me see if I can find it. Let me see here. Oh, doggone it, that thing is in the way. There we go. That'll work.
Get Amazon here. I'll just look at it here and see if I can find it in my you guys can't see this, can you?
No,
Okay.
I made a thing like that out of wood for when I'm out camping and stuff, and it works great,
Uh-huh.
but it doesn't collapse, and it's sort of hard.
Oh,
and bulky.
yeah. Let's see if I can find it. I don't know if I can. Yeah, that's gonna be a tough one to find. Yeah, I'll see if I can find that. I'll shoot you over an email maybe,
Okay, thanks.
and do that right there.
Yeah.
So let's see, are we still on? Yeah, we're still there, right? Okay.
Yep.
All righty. So what I did was I said, okay, what I did was I did compositions on both of those panels. Now I only did 7-minute and 3-minute. So I'm a little bit concerned here that I don't have enough layers in there, because the more layers I put in there, of course, the more it's going to bring down the brightest areas. They call this HDR composition. The HDR, one of those acronyms, stands for high dynamic range. So what you're doing
another acronym.
Yeah, another acronym. Yeah. So what you're doing essentially, though, in intelligence terms, is you're basically bringing down the brightest areas, and that would be the stars. See, and that's where I'm going with this, because I think that's why that M31 picture came out so well. So I got a panel. This is the first panel right here. This is seed 214, and this is NGC 7822. This is just basically a raw stack composition of 7 and 3 minutes. So no processing's been done at all, and then I just did a screen stretch to stretch it up. I got some kind of weird thing going on down here, and I'm not quite sure what that is, and I'm going to guess that it could be something that's with the sensor, but I'm not sure. So you can see I kept pretty good precision here. This hasn't been cropped at all. So from night to night, everything is good. I don't know what this cluster is over here. It doesn't register.
I was wondering that.
I have no idea. I really don't. And I don't even know if it's a cluster or if it's just a group of stars that have to be in the same place. So this is the one side. Okay, this is panel 1. And then panel 2, and this is going to blow your mind too. You're going to be going like, I know what's going to happen next. You're going to ask, why is that color and the other one the other color? And I'm going to have to tell you, I don't know. But just different sky conditions. So you're looking like right around there. Okay, I'm just kind of, that's basic. You got about 60% overlap. So it's going to be real happy on the overlap.
Dick, what are the objects? I'm going to look this up later.
Seed CED 214 is one, and
Okay.
that's short for cedar blad, I believe. Cedar blad. Okay. And then the other one, which is the more wispier one to the left, that is NGC 7822.
Thank you. I'm going to look those up. I'm going to find out what that cluster is.
Yeah, that'd be really cool if you do that, because I could.
Yeah, I'm going to do that.
Now, the only thing I could think of is that these days were real windy. It was really, really super duper windy. And so I'm guessing that maybe that the sky background color is different. But anyway, what I'm going to do next with these guys here is they have to get their backgrounds neutralized. That takes about a half an hour, because I got to select about 1,000. I select around 1,000 points. I just go around here and select areas where I think the background should be. And then it goes through and figures that out, and also does a pseudo white balance on the whole thing. So you get basically a sort of a color balance out of the whole thing. And then after that, photometric color cal. Once that's done, I run this program. It's called DNA Linear Fit, and where you have a reference panel, and then you try to make the other panel like that reference panel by using the overlapping regions between the two to make the other panel the same. And so I run that, and then once that's done, I can start to build a alignment template. That's the first thing. And then, so what it does is it just basically builds a mosaic without doing the blending and all that stuff. So you can get the sizes of everything, where they go. And then you build your merge mosaic from that. So that all has to be done. And then once that's done, you have to do the rest of the processing after that. So I'm still not there. But one of the other things that I did do that I thought was really kind of neat this time is I did a 24 millimeter shot, 24 millimeter imaging of with Saturn in the middle, centered on Saturn, which is the central star in the constellation of Cygnus. Okay, so it would be the center cross star in the northern cross portion of that guy right there. And it's the most number of frames that I have ever stacked at 47 frames with that 24 millimeter lens because of the perspective changing, you know, and how it projects itself on that sensor. By keeping that fixed over that, it was like over a 4 or 5 day time period when I was doing all this. You can see the Cygnus loop. I mean, I haven't even done any processing on the thing. And I'll show it to you. Well, I'll probably have to pause here for a second because I got to pull it up. But I gotta tell you this much right now: the detail in it, I'm pretty incredible. It's pretty incredible. I can see the eastern veil pretty well, and the western veil is somewhat visible. And this is before I've even processed it. So I gotta tell you right now, I would say this is gonna probably end up being the best 24 millimeter image I've ever done. So I'll try and pull it up here in a minute here. So it takes time. But that's where I'm at on those guys right there. And I'm really interested in seeing if I can pull this off, because if I can make this thing work with that kind of a transform, I think I'm going to be miles down the road to making this much better, you know, for mosaicing. Because I keep getting the artifacts, and I just want to try to get rid of this stuff, you know.
Well, I tried finding that cluster, and every time I tap on something, I just get single stars. So I can't. I'm in Sky Safari, but I can't find it.
Oh yeah, I had something. I don't know if it's not Sky Safari. It's kind of the one that it's like that. It's probably a cheaper version. It's the one that Orion had, and I couldn't find. I looked and I looked and I could not find the freaking thing. So
yeah. No, me neither. I can't. It's not going to show up. I don't know what it is.
Yeah.
There's a lot of stuff going on there.
There is. That's one of the things I liked about the area, and it's so huge too. Those two clusters are fairly large. Here we go. I can pull this up now. Maybe here. Let's see what we got here. Oh, here we go. Okay. Now let's see. Yeah, that's it there. Okay, so like you can see the North American pretty well. I'm hoping I can get down here so we can. The problem with this doggone thing is I can't scroll very well. So I don't know if I can get it into, because of the stupid. Here, let's see. No, there we go. There we go. That'll work. Okay, now I need to get it here. We got to find out where it is. Okay, let's see here. It's naneb. There's Saturn. I'm trying to figure out where the loop is. There it is. Yeah. Without any, see, there it is right there. That's the eastern veil. There's the western veil right there. You can actually see that image on there. I haven't done anything with this, guys. It's the raw stack. So I haven't done any enhancements or anything like that. So you can see there's the western veil right there. There's Cygni 52.
51 Cygni.
Is it 51? Yeah, one of those. And then there's the eastern veil right there. And on the other one that I did, I can't see anything. I really cannot see the eastern or the western veil. I can't see Pickering's triangle, but or any of the other ones. There's Pickering's triangle would probably be in this area over here, and I cannot see that one right there. But I was really impressed when I saw that. That's the best imaging I've ever done with that 24mm lens. So I was really stoked on that. That's about 47 frames at 6 minutes. The exposures each ISO 800, and that 24mm lens stopped at f4, the f1.4 Red lens. So I'll be happy to see you. I'll be able to give you guys some results next time, show you what it looks like. That's all I got.
Very nice. Yeah.
Tim, did you want to show your telescope tester?
You can. It's just so simple after what I've seen tonight. You
Oh,
guys,
come on.
No, you know what I did is you can see that what I did is I got rid of that other LED and I put the smaller LED in. And you know, the one that I was using was like a 3/8 inch LED. And the one I put in, it was like a 3.2 volt and 20 mega amp. And this thing is it's a 2.2 volt and 20 mega amp. And it's just a smaller LED. And then I took out that other resistor. You can see the resistor I resoldered back in there. And
Hey,
I went and
Tim,
got my
hey, Tim, it's not mega amp, it's milliamp.
Milliamps.
milliamp.
I was hoping.
Sorry.
Well, I tell you, if you had some mega amps, that would be something else.
Well, the milliamp, 20 milliamp, and the but a 2.2 volt, and it's a much smaller LED. It's only like a 1/4 inch. It's like a 5mm LED, and then I couldn't think what type of a resistor I put back in line. So I went and
It
got
looks like 150 ohms or something.
It is 150. I found out that I have a book at home here, and it said the first 2 stripes, they're numerical values, and then the third stripe is how many zeros there are, and the gold and the yellow bands, they really are just a percentage of accuracy. That's all it means. But the first brown band is like a 1, and then the green is a 5. And then the brown means, you know, there's 1 0. So it's 150 ohm resistor, and it just worked great. I could dial that thing down. It wouldn't go dark, but it just went, it went way down. Plus the thing that Hank or Tom brought up that Hank talked about, what was it, a JMW or
PWM.
PWM, yeah.
Pulse
And-
width modulation potentiometer in a sense.
it's PWM.
Yeah.
Yeah.
So I looked that up. When the one that you had up, Tom, I looked that back up. It was probably the only one on Amazon. It's only $6. I'm going to order it anyway, but it's exactly what it needs. So I can order it. But you know, this worked fine.
Yeah.
This worked fine. Now I'm just going to create a slit, find a dark place, and go after it. You know, so it's much better. The other one was just too bright. I just couldn't. I mean, of course, where I'm testing during the day, it's so damn bright. It worked great. Yeah, that's it. That's it right there. And you know, it's just perfect for what I want to do. But you know, I don't need it. The way this thing is working, it pots down to a damn near dark. So it's really good.
Wow. Good job. By the way, it was 52 Cygni, not 51.
Okay. Okay.
Yeah, 52 Cygni. It's smack dab in the middle of the witch's broom.
Yeah.
That's the, what is it? The Western Wall.
But that's
Witch's
Western
Broom.
Vale. Yeah, Western Vale. Yeah.
But they also call that one. That's the one they call the witch's broom.
Yeah.
Right. Yeah.
I love that. If you get a dark place and kids are around, and you can tell them you want to see the witch's broom.
Yeah. Oh yeah.
And
Okay,
then,
I'm getting an allergy attack. I'm going to sign off. Good night, guys.
Hey,
See you
Jerry.
next week.
Hey, thanks for
Right.
sharing that mirror cell. That thing is just absolutely unbelievable.
Sure. Yep. Okay. Good night.
Good night, Jerry. Yeah, we can, thanks for letting me show you guys that. I was really stoked to find that. I still have to find a dark place to test, but you know, I've been working on that guitar a lot, so I haven't had the time to go get after it, but I will. I'm almost done with that guitar, by the way.
Wow.
Yeah, I'm almost done. I got, you know, I actually glued the bridge on, and that was a trip. It, you know, it has to be really precise, and I use that. It's kind of scary because you have to do it quick, and using hot hide glue, you have to really go fast. And so I got away with it. It looked really great. So I'm stoked about that. I'm almost there.
We're waiting for the music, Tim.
Yeah, geez. Yeah, not for me. I'll go and get somebody. You know, there's a guy that we played tennis with. I didn't even know this. I got a you know, every once in a while, Guitar Salon International, they have people go down there to LA and they perform and they record it and they send it to you. And there was a guy from Santa Barbara. And I thought, yeah, there it is. That thing's it's almost done. The bridge is on now. The frets are all on there. I sanded it all out. It's all ready to go. Yeah, it's looking good. Anyway, there's a guy, Tom, that was down there playing tennis. I didn't even know this. The guy's a really good flamenco player, and he's kind of world renowned. So I thought, you know, if I finish this guitar, maybe I can get him to try it.
Yeah. Sure. Why not?
But yeah, but I mean, it's, you know, it's first of all, I got to see if it even makes a sound. Supposedly when you do the first one, you get kind of a bad shock, and I'm waiting for that. It's all right. It was fun building anyway.
Yeah.
But I'd love to finish that scope.
Get that mirror done.
Yeah,
And
Tom, that was the first mirror I ever got. It was an 8-inch mirror that I got from that guy Doug that had Douglas telescopics back when I was like 21 years old.
Yeah.
So I had it for that long ago. I'd love to finish that thing, but God, it's like the mirror from hell. I can't get rid of it. The problem is, I'll get it. I'm really close. I just got to be able to sneak up on it now and be able to test it in a dark place.
Did
And I'm
Jerry
gonna
make
get
that
rid of
mirror?
help.
Is that mirror that he is for that big scope that he's doing? Did he make the mirror for that too, or?
Jerry?
Yeah.
Yeah.
Is it an 18-inch? I think he said.
Yeah.
Yeah.
Wow.
Jerry does all those. He does
What a
his own-
dude, man.
Oh
He
yeah.
He was making the 10 and the 14.5 and the 18-inch mirror all at the same time.
Yeah.
Oh, Mark.
Yeah, and he does, and you know, he literally in the workshops, he literally gets angry with me because I won't listen to him with his advice. He only wants me to do one thing. And I said, oh no, do 10 all at the same time. You know, and he goes, well, how are you gonna know if you did the right thing? You know, I said, well, you're right about that. So I kept getting in trouble, turning edges on the mirror all the time. And I never had that problem on the 10-inch I did. You know, I never had a problem. You went all the way through the process, finished it, still got the 10-inch. And
Does he teach the class? Does he teach the telescope class, or
no? That would be Tom Whittemore. Tom Whittemore has been here a couple of times, and Tom Whittemore. What's that, Tom?
Well, there's a couple of plates that were Douglas Telescopics garage that came out of there. I think they're metal, and you know, there's a interesting form, a silicone form that he has. It has hexagonal ports in it. Let me see if I can see it in one of the next pictures here. Where'd it go?
Is that bathroom tile?
Yeah. What's that? Yeah, it's a tile. No, I don't know if it's tile or not. Dang it. Where'd that go? Thought in the same group here. Oh, down here. See this thing? Let's see if I can zoom in on this. You know, try to keep a record of what's in the shed here. And there's
like a mount.
you see that orange thing in here?
Yeah.
It's like you lay that down and then you put your lap, this on top of the lap or something. It's very thin. It's only like
Right.
maybe an eighth of an inch thick, maybe less. And you lay that on top. And so, and there's a couple more tools in here, Tim. If you were looking for another 8-inch mirror to work with as a tool, you know, we might
Yeah.
have something that you could use. So if you ever
Okay.
want to look in the shed with me, we'll do that.
Yeah, I
If you
might
need
do
a
that,
tool.
Tom, 'cause I still have, you know, when we ever get back doing the astronomy days, I always took an 8-inch mirror and all my whole setup and showed the kids how to grind a mirror. And as you know, I
That's
did
true.
that, and I ended up taking, I think the mirror I'm using, I ended up grinding it all the way through to the whole process and finishing it out. Now I've got another one I'm doing that's ready to polish. And you know, so there, and then there's another one waiting in the rings, but I don't think I have one beyond that. But if we ever get back doing outreach, that's going to be what I do. Although,
Tim, I thought that one mirror took you 10 years, right? Or it was a mistake? And now you've got
No,
another
I
mirror,
did-
you say?
this one I'm making, this 8-inch here, I bought the kit from this guy Douglas back when I was like 21 years old, and I set the whole thing up, opened the book, couldn't figure it out, and I put it away for 35 years. And then I came to the club. Tom Whittemore said, "I know how to make astronomy mirrors. Anybody interested?" And I went, "Well, yeah," you know. But and I made a 10 with him, and another partner that I worked with was Jeremy Schmidt, who was a physicist. He was doing his doctorate out at UCSB. But the 8, this one, it's like the mirror from hell. I keep on making mistakes. I've been working on it now, probably going on 3 years, and that's ridiculous. That is ridiculous. I've had guys came up to me and literally made me feel like crap by saying, "Oh, are you kidding me? I could do an 8-inch mirror in a day." You know, I just said, "Oh, great," you know. But you know, it's
You really have to concentrate it in a small amount of time. Like maybe you spend like 1 hour a week over 52 weeks, and you
Yeah.
lose track in between each week. So it's
and then I had all kinds of problems. We had some cerium oxide, the final polishing compound, and you taking? Oh, we're gotta go.
Yeah, I'm gonna be leaving. Yeah.
it's
Okay, all right, guys. Well, anyway, I'll keep working. I'll get in touch. I'll see you guys all later. Okay.
Okay, great, Tim.
Thank you.
We'll say good night.
Good night.
Ending the meeting.